All right, welcome to the Projectile Motion Lab. All right, I'm going to give you the lowdown on how to hook everything up and set it up and get it ready. And so as you can see here, we have the table clamp. We clamp this to the table. We're going to put this metal rod inside of the clamp. We'll tighten this screw to tighten it up. Make sure that we have at least a meter up to the top. And at the top up here we have the mini launcher. So this is the ball launcher. We have the clamp that holds the mini launcher to the metal rod. And then on here you can actually see the compass, right? And so this will tell you what degree you're at. If you loosen the screw on the back side, and then you can loosen the screw on the back side, and then you can change the angle accordingly. Now, one thing you got to keep in mind when you're doing this later is as you change the angle, what happens? The top of this actually moves up, and so if you look, you have to be careful, because if you look at that, you're going to find that it's above 1 meter, and you want to keep the distance from where it launches, or the bottom of this barrel, right? You want to keep that at 1 meter. And so we use a meter stick, put it on the desk, lean it up there, and we get everything situated just right so that we have 1 meter above the desktop to get to here. And so as you change this degree later when you're doing your different angles measurements, right, just make sure that the bottom of the barrel always is at 1 meter. That's a key. Okay, so we're gonna mount this on here, and so just so you can see the back side, right, these are the two screws that hold the mini launcher in place, and this is the screw that mounts this to the actual bar, right? So you tighten that up and it'll stay. And so I'm going to put it back over here. I'm going to make sure that we're back to 1 meter. Okay. You don't have to go crazy with cranking these things down and making them so tight that you can never move them again. Right, but you do want to angle it so that it's going to land on the desk. So this is one of the key pieces, right? So you want it to be able to go, and it's going to land on the desk. So what do we have? For the first part, we need 0 degrees. Why? Because we want all the velocity that this thing is going to give only in the X direction, which means the velocity in the Y direction, the initial velocity, is going to be what? It's going to be 0, right? It's not going to be going down at all. It's just going out. So then it's going to start from 0, and it's going to start falling as it goes. All right, so what do we have here? Right here we have what? We have the table clamp. We have the rod inserted. It's clamped to the desk. Then up here we have the mini launcher. It's clamped to the bar. Its height above the desk is 1 meter, which we can check by putting that there. You can see it's 1 meter from there to the top. Okay, everything is good because we're at 0 degrees. It's pointed down the desk, so when this thing launches, it's just going to fly down the desk. And over here we have some carbon paper, and we have some white paper. And so what we're going to do is we're going to set this thing, push the ball in, which I've already put the ball inside. There's a little magnet that holds it so it won't fall out. And over here on the back side of this is the ball push rod. Right? And so you're going to push this, right? Here's the little launcher mechanism. You're going to push this, so what? You're going to push it till you hear the first click. Right? There's actually 3 settings, 3 clicks that you can get to. Each one is a little more high powered than the last, right? Because you're compressing that string a little bit farther and a little bit farther. We only want the first one, and so now this thing is ready to launch. We've cocked it, we've set it up, everything is good, And so what we want to do by first time is we're going to figure out what the velocity of the ball is from this first notch on the spring, because we don't know that. And so what are we going to do? We're going to use the change in x to figure that out. So I'm going to go ahead and launch it, and we're just going to see where it lands on the table over there, and then I'll put the actually put the paper there with the carbon paper on top so we can actually do some measurements. But so let's just start with the first one. Whoa, that went a lot farther than I thought. All right, so we made the launch. I figured out where the ball landed. Landed right over here. And so what I've done now is I've taped that paper down, and now I'm going to put on top of it this carbon paper. Do not tape the carbon paper down. Only the white paper gets taped down. Right? This does not get taped. All right, so now I've reloaded everything. I've put the carbon paper down on top of the white paper, as you can see there. And so now we're going to do our first launch. Now, just to see, you can see the black dot on the paper. Now we're just going to do this 4 more times. All right, now we made 5 shots, and you can see there that all 5 shots land pretty close together. All right, so now that we've done our 5 shots, right, now I need to do what? I need to measure from where this thing is lined up here all the way over to there where it landed. And so if you look here, you'll see this white circle, and inside the white circle is a little crosshairs. That crosshair in there represents where there's no more acceleration. In other words, it's left the spring. So now it's just in free flight, and it's just going to head on out that way, right? So what I need to do is I need to figure where that is. So I'm going to use this plumb bob to figure that out. And I'm going to hang it so that the string crosses over the center of that crosshairs and then hangs down to the desk. And where that thing is down here is we'll measure from where we're starting from. And so it's about right there, which is about, looks like about 3.5-ish centimeters. We'll just call it 3.5. So the end of this barrel is 3.5 centimeters off of the desk. So now when I use my ruler, as you can see here, right, as I use my ruler, I can measure from here to there, and I'll add those 3.5 centimeters to it, right, because I know that it's not on the table, it's off the table. And so then you look over there and you would say, okay, I have, whatever it is, 91, 20, 30, 40, so it's like 143 centimeters or whatever over there, plus the 3.5 off, so 146.5, right? And I would measure each one, and each one will give you your 1 through 5 on your x direction distances over there. And you put those in your table 1, and using those, you can figure out the overall velocity or the average velocity due to this first setting on the spring. Okay, now that we've done that, what do we need to do? We need to do uneven surfaces, right? So above the surface, but we've got to do this at different angles now. And I'm not going to go through all the angles because I think it would be redundant to show you, but I am going to show you one. So what you're going to do is this little plumb bob hanging here says we're at 0 degrees right now. So I'm going to loosen that back screw just a little bit, and I'm going to move it so that that string is now at 10 degrees. So now we have the launcher set at 10 degrees, and so the ball, when it launches, is going to launch with some of the velocity in the y direction and some of the velocity in the x direction. And so we're going to have to make sure that Our barrel is at 1 meter, though look, see now it's much higher. So what do we got to do? We've got to just loosen the screw on the bracket and lower the whole thing until we're comfortable with all right. So now what do we have? We have this thing set at 10 degrees. The end of the barrel is 1 meter above the desk, and we're ready to go for a 10-degree shot. So I'm just going to load the ball again, stick it in, little magnet in there holds it in there. Gently push this in till you hear the first click, and now we're ready to go. So now we need to do what? We're going to have some different position where it's going to land, but I think we're going to be somewhere over there, so it's all good. I'll just go ahead and launch the first one and we'll see what happens. All right. All right, so we're just going to do that 3 times. And if it hits the desk, really it's okay. We've got some isopropyl alcohol we can clean that up with. And so we'll do shot number 2. And here we can see the new dots. And so we can just measure to the new location, right? And we can figure out all the pieces. So there was our first set that we used for the no angle where we were trying to figure out the velocity. Here's our first angle of 10 degrees, and then we'll do 20 degrees, 30 degrees, 40, all the way up to 80. And we'll see what the differences are. All right. So with that being said, I'm not going to do any more of those angles, right? You can do the rest of those angles, that's no problem. I am going to show you how to do the desk one now, and that'll be your last one. Okay, so here we go. So we've taken the bracket off of the metal bar that's over here, right? And we're just clamping it to the table using one of these provided C-clamps. Now make it snug, but you don't have to crush because this is only plastic, right? So you don't have to crush that down. Just make it snug so it doesn't move, and then we're good. And so, as we look around on this side, what do we want to do? Well, we want to make it so that the edge of this barrel is flush with the desk. All right, so we use the meter stick. And so the top of the desk is on the bottom of the ruler, and so you can see there that the ruler is right at the bottom. Now I've already set the angle, as you can see over here, I've already set that angle to 10 degrees. So this is now a 10-degree angle flush with the desk, so then it's going to leave the barrel and launch up and go some distance down the desk. So with that being said, I'm going to move you over here. And we're going to have a look-see. So this works just the same way as before, but now we're doing what? We're using an even surface, right? We're using this nice even surface to do our work with, and we're going to figure out like how far it goes in this case. All right, so I'm going to load the ball in the chamber there. Got the first click. I'm going to see where it lands first here. Well, that didn't go very far at all. All right, so let's load that in. First click. Okay, and punch. All right, and I can see my first black dot is right there. And so now you can just measure straight from the crosshairs, right? So I can line this up directly with the crosshairs, and now I can measure, and so I can see that my first shot was basically 42 and change, 42 centimeters and change. And so now we're going to do this for a total of 3 shots at 10 degrees. So that's 1. Put my paper back down. And 2. And 3. Oops. Put my paper back. Alright. Nice. And now we can see the first 3 shots. And we can measure where they are. And so we can measure over to there. And we can see the first 3 shots from our place. And we can see that it's like 42 and change or whatever. So now you're going to just take that and you're going to do that again and again for 10 degrees, 20 degrees, 30 degrees, so on and so forth, all the way up to 80. You're going to figure out, in this case, you're going to figure out, okay, or both cases actually, you're going to figure out, okay, which angle gave me the longest, right, the longest range, or went the farthest on the table. And you're going to answer some other questions about, you know, well, what did you get with some other angles? How does that relate to what you think or what you know already? And so on and so forth. So, with that being said, I look forward to see you in class.